The Light Phenomena. Lesson 5, Learning Resource 5.2. A mirage is an optical illusion caused by repeated refractions of light by warmer air near the ground. This results in apparent road wetness. The primary colors of light are red, blue, and green. If equal intensities of these primary colors of light were shown on a spot, the spot would be white. All other color produced by mixing suitable portions of primary colors are called secondary colors. Red and blue is magenta, red and green is yellow, blue and green is cyan. The color of such an object depends on two things: the color of light that is shown on the object and the color of light it reflects. A transparent material selectively absorbs one or more frequencies of light and transmits what is not absorbed. The color of a transparent material is the color of the light it transmits. This explains why light from a red laser passes more easily through red cellophane than green cellophane. Some opaque objects absorb only specific wavelengths of light and reflect others. A red apple appears red when illuminated with white light. It reflects only red component of white light and absorbs the other colors. When illuminated with blue light, the red apple appears black, when it absorbs all colors and reflects none. When illuminated with yellow light, which is green and red, it reflects the red part of the light and absorbs the green part. Hence, the apple appears red. The atmospheric optics. Some optical phenomena such as the twinkling of stars, halos, sundogs, and rainbows are made possible by the refraction of sunlight caused by the small variation in the index of refraction of Earth's atmosphere. These variations are, in turn, due to the difference in the density of air as a result of temperature variations. The light refracted by ice crystals suspended in the atmosphere produces halos and sundogs. Halos are rings and arcs of light that appear in the sky. Sundogs are rainbow-colored splashes that may appear as a part of the halo. The moon may also have halos and moondogs. Sundogs got their name from their position relative to the sun. They seem to be watching and protecting their master, which is the sun. A rainbow is formed after a rain shower. A primary rainbow forms when sunlight is refracted as it enters a raindrop, then reflected on the inside surface of the drop, and refracted again as it exits the drop. When light is refracted twice within a raindrop, a secondary rainbow is formed. When the raindrops are nearly of the same size, a set of fainter bows, which usually consist of pale pink and green colors, inside the primary rainbow may be formed. These bows are called supernumerary bows and are formed by the interference of light coming out of each raindrop at slightly different trajectories. Clouds contain a lot of water droplets and ice crystals that are large enough to scatter almost equally all components of visible light. This causes clouds to appear white. However, as clouds gather more water droplets and ice crystals, they become heavier and thicker. Clouds that contain too much water droplets are rain clouds. More light is scattered, resulting in less light penetrating all the way through them. Moreover, if the water droplets near the cloud base grow larger, or just before the water droplets are heavy enough to fall, they become fewer effective scatterers and more effective absorbers of light. Thus, rain clouds appear dark. Rayleigh scattering is accounts for the blue sky and the red-orange sunrise and sunset. When sunlight enters the atmosphere, violet and blue lights are scattered the most. However, eyes are more sensitive to blue light than to violet light. Thus, the sky appears blue. At sunset, sunlight travels farther through the atmosphere. Longer distance would mean that much of blue light, having shorter wavelength, have been scattered, leaving only yellow, orange, and red because they have longer wavelengths to be scattered. Thus, a red-orange sunrise or sunset results. How Hertz produced radio pulses. Heinrich Hertz was a German physicist who invented an apparatus that could produce and detect electromagnetic waves with frequency outside the range of visible light. His apparatus consists of a primary coil and a secondary coil with many turns of the wire. The secondary coil leads to two metal balls separated by an air gap. When a current is alternately started and stopped at the primary coil by means of a vibrating switch, a high voltage is induced in the secondary coil and sparks are produced between the metal balls. Ordinarily, air does not conduct electric current, but when there is a large potential difference between two wires at a short distance from one another, air molecules are ionized and a short burst of electric charge may pass through the air. The sparks are visible evidence of quick motion of charge. In using this apparatus, he was able to produce radio impulses.